voltage, output, and also ground. So there are two pins actually, two pins that is very important for us to complete a circuit when we are connecting it to a sensor or external component. So what voltage output is to support the supply for the external components or device that is being connected to the board. This is to power up the components and devices that is being connected to the board. There are two options of voltage pins. One is the 5-volt pin, and the other one is the 3.3-volt pin, depending on the voltage consumption of the components and devices. So if your sensors or components are using 3.3 volt, then you connect it to the 3.3 V pin. So there are two pins here. One is the 3.3 V and one is the 5 V. So we connect it depending on the power consumption of the device. So but most of it uses 5 volt. Okay. So then we have another pin which is labeled as GND, which stands for ground. This pin is to complete the circuit for the components or devices connected to the board. This Arduino board has total of 3 ground pins, one 5-volt pin and one 3.3-volt pin. So you can see on the other side, there's one pin, GND pin. Here we have 2 GND pins, and then we have one 5V pin and another one 3.3V pin. So these 2 pins are used to complete a circuit for external components, because you need to power up your sensors as well. So this is in function for those external components. Okay. So next we'll take a look on digital pins on Arduino. So as we look here, this side, it's all digital pins. There are a total of 14 digital pins starting from pin 0 up to pin 13. So there are a total of 14 pins. These pins can only be triggered as 1 and only 0. So their output is actually 1 and 0. I'll explain on it later, where 1 means on and 0 means off. This pin on the Arduino can be configured as either inputs or outputs. So basically, digital pin input and output can be only on and off. So if you are talking about digital, we only can trigger on and off only. And also the output, we can know it as on and off. You can get the reading. So you can turn on and turn off a device or read if the device is on and off. So you only can trigger 0 or 1 only. But it can be used as output and also input. So this row is all digital pins, 14 digital pins. Okay, now we will take a look on analog pins. So this is the analog pins. There are 6 analog pins. Starting from pin A0, it's not A, it's A0 up to A5. So there are only 6 pins. These pins can be only read analog input only. I will explain on what is analog on later. So if we are going to read more than just on off, so as I mentioned, digital only reads on off, but you're going to read more than that. You're going to read the value of the sensors that is giving. So we are supposed to use analog pins. So that's the difference if you're going to between these 2 pins, analog pin and digital pin. Okay, so now we can see that's 6 pins here, starting from A0 to A5. This is all analog. Analog, we will have the exact reading. So let me explain more in details what is exactly is input, output, analog, and digital readings are. So what are they actually meant? We'll take a look now. Okay, input. Inputs are actually signals or information, or we can say data that is coming into the board. So whatever data that's going into the board is input. Any device which can provide input is called an input device. So whatever sensors, device components that can give us an input, they are called input device. Let's see some examples of input devices are sensors, buttons, keyboard, and mouse. So why would I say these four are input? Because this can give us an input information. It's a reading, and they provide information to the Arduino. So as I mentioned, sensors, buttons, keyboard, mouse. So when you, for example, keyboard, when you type in alphabets, it actually gives the information, the alphabets. So that is why these are categorized as input device. Okay, let's see output. Outputs are actually signals, information, or data that is exceeding the board. So whatever data, information that is going out from the board, they're actually output. Any device which can provide output is called an output device. So some examples of output device are LEDs. So these LEDs can give us an output. And so motor, or known as servo, printer, monitor, and actually there are many more output devices. So we can compare this between input and output is that input is any form of information that we pass in the board, and output is anything that we are able to visualize or hear. So let me give you a small example. Input are the information that's going into the board. Just say the sensors are giving you information to the board. And then output are the information that we are able to see. For example, as I mentioned, LEDs. When the LEDs turn on, we are able to see that. When the motor is running, we are able to see the motor running. For printer, we can actually print out the paper. And also monitor, we can see our display. So whatever we can visualize, they are actually output. So that's the difference, common difference between input and output. Okay, let's take a look on analog input. Analog signal uses a range of values to represent any kind of information in the form of numbers. So there are values that represents information in the form of numbers. As you can look at the graph, you can see there are ups and downs representing the fluctuation of data, which can be a range of value receiving from the input device. So you can see there's an up and down. So each up and down is representing a value from the input device. So it can be a range of values from negative up to 1,000. Some examples of analog inputs device are temperature sensor, humidity sensor, light sensor, pressure sensor, and there are actually many more sensors. So these sensors data will be in analog reading, which can be read by humans. So all these readings will be in the form of numbers, so that we are able to see the number and then do other functions with it. So analog are actually, in short, analog, we use analog input for able to read information, a range of values. The values are in form of numbers. Okay, so now you take a look on digital input and output. So digital signal uses 0 and 1 to represent its information. Compared to analog, it uses value. This digital uses only 0 and 1 to represent its information. 1 here means true or high, or maybe on. Whereas 0 means false, low, or off. So as you can notice, okay, let's take a look at the graph. You see when it goes up, it's 1. When it's down, it's 0. So it only can give you 2 readings, either 1 or 0. So when it's 1, means it's on, and then if it's 0, it's off. So that is the 2 value we can retrieve from a digital input Okay, for example of digital input device, we have the proximity sensor. Okay, let's take the example of proximity sensor. Data received from this sensor will be either 1 or 0. What are the 1 and 0? 1 will be representing if the objective is detected, and 0 means objective not detected. So proximity sensor is a sensor that detects an object in front of the sensor. So when you read from the sensor and it shows you 1, means it's detecting something, and if the value is 0, means it's not detected. So that is how we can know that the sensors are giving us value. Okay, for example of digital output device, which is LEDs, relay, or motor, or either buzzer. And the same way, we can turn on and off the sensors by simply triggering 1 or 0 to the sensors. So, for example, I'm going to turn on the LED. So I make the pin, I give the value as 1. So the LED will turn on. I give the value 0, the LED will turn off. Same goes as relay and buzzer. When you give the value 1 to the buzzer starts to ring. When you give the value 0 to the buzzer, you will stop ringing. So for digital, this is all for digital. You need to understand this. It gives you value of 1 and 0. If you read it as 1 and 0, the value represent 1 means it's on, 0 is off. Compared to analog, it gives you a value. So if that is what I meant, if you want to know more than just the device is on and off, we use analog. So if there's light, if you're going to read there's only light, then we use digital. If you're going to read the light intensity, then we need analog to read how bright is the light. So that is how we can differentiate between digital and input, and this is how you can use either digital or analog. Okay, so that's it. We covered for the main components for both Raspberry Pi, and also Arduino. That are the main components we should know before using it for both Raspberry Pi and Arduino. Right. So let me show you the Arduino connection with the Raspberry Pi. So USB type A, I showed you just now, you'll be connected to your Raspberry Pi. As you can see on the image. And then USB type B will be connected to the Arduino. So this is the cable. This is the only cable we're talking to both Raspberry Pi and Arduino. So for different cables, we'll be using is because different board. Not all Arduino uses the same type of cable. Different Arduino boards uses different types of cable. If you remember Arduino Leonardo, it uses micro USB type B. So this is USB type B, that is micro. So different boards uses different cables. So the communication between these two boards is called serial communication. So serial communication is wired. The communication between these two boards is transferred through this wire, and it's called serial communication. So what is exactly serial communication? Okay, serial communication is a simple way to transfer a data between two data processing equipments. So a Raspberry here is one equipment, and Arduino is another equipment. So this is a process of interchanging of information between these two individuals. When these two interchange information between these two devices, we can simply use serial communication to achieve this. The data will be transferred using the cable connected between these two devices. So the cable just now we saw is connected, that is how the data will transfer. Hence making this connection a wired connection. So this is unlike wireless, this is wired. So in serial communication, there will be a sender and there will be a receiver. So what does the sender do and what does the receiver do? A sender is the individual that sends out the data. Then a receiver is the individual that receives the data. So you can see on this slide image here, you can see this PC here is sending the data to another PC, and that PC will receive the data. But in our case here, the Arduino will be the sender and the Raspberry Pi will be the receiver. And then remember that the flow is always from the sender to the receiver. Once the Arduino has received the data, it sends to the Raspberry Pi. So that serial communication is quite simple. Right. Now let's take a look on some differences between Arduino and Raspberry Pi. Okay. So these are the simple and most common differences between this Arduino and Raspberry Pi. An Arduino is a single microcontroller board. So as I mentioned, microcontroller board is actually a board that is programmable, which we can write code and upload it. Whereas a Raspberry Pi is a mini computer. Like I mentioned also, it's a mini version of a computer, but works exactly as a computer. Arduino can only run one program at a time. Okay. Meaning is, once the program has been uploaded to the code, to the board, only that particular program will be running constantly. So once you upload, once you have given your program is actually an instruction, it's mentioned instruction, how do you want your board to work? Once you upload the program into your board, only that particular program will be running constantly. Whereas Raspberry Pi can run multiple programs at once, meaning 2 or more programs can be run at a single time. So it means you can open this program, you can do this function, and you can also do another function simultaneously. So that's the difference. The Arduino does not have any kind of interface. So the Arduino is just a board with no interface. But it has a software which is called the Arduino IDE. We will go through it hands-on tomorrow. It has a software called Arduino IDE, where the program can be that is the software we use to write the programs and upload it to the board. So that is our only UI. The board doesn't have a UI. So that is actually the software to write the program, to write your instructions, and then you upload it to the board. Once you upload it, you only run once. The Raspberry Pi graphical user interface is visible at the screen during power up. So once you power up your Raspberry Pi, once you connect it to your monitor, the monitor should show you a UI, and that's the UI for Raspberry Pi. Similar to a computer, you connect your PC to your desktop, and your desktop shows the interface, and that's the interface, similar to the Raspberry Pi. And also, the Arduino has also both digital input and output and analog input. So I hope you still remember what's digital input and output, analog input. Whereas the Raspberry Pi has only digital input and output. It does not come with analog. So these are some of the differences between Arduino and Raspberry Pi. We go through again. Arduino, a microcontroller board, whereas Raspberry Pi is a simple computer. You only can run one program at a time. Raspberry Pi can run many programs at a time. Arduino got no interface, only the software. And the Raspberry Pi has a UI on the monitor when it's powered up. Arduino has digital and analog input output, whereas Raspberry Pi has only digital input output. These are the common differences between these two boards. Okay, here are some applications of Arduino and Raspberry Pi. So we just listed down some of the common applications that is able to develop using Arduino and Raspberry Pi. Some of the Arduino applications are security system. You can see the first one is security system. This security system can be done using fingerprint unlock or RFID. So if both ways are applicable to develop this security system. You can use your fingerprint to unlock your door, or either a RFID card to unlock your door. Either way. Then we have the home automation system. Home automation is basically turning on off your lights or your fan in your house. So you can use Arduino to develop that as well. You can turn on your fan, your lights. When you go out, you turn off your lights. simple controlling system around your house. Then we have the weather station. Arduino can develop this is all simple applications. So the weather station is to display simple weather reporting informations, like what's the weather around. Arduino is able to do all these simple systems. Let's take a look on Raspberry Pi application. The first thing, as you all know, Raspberry Pi is applicable on replacing your normal PC with a Raspberry Pi, which works almost the same. So we can replace your normal computer with a Raspberry Pi, which is lower in power consumption, smaller in size. It's the size of a credit card, I could say. Then Raspberry Pi can be used as a web server, meaning that you can host your websites on the Raspberry Pi, making it into a server. So you can host any of your websites inside this Raspberry Pi. It works as a normal web server. Then finally, we can use Raspberry Pi to develop games using some of the software that is already pre-installed in the Raspberry Pi. So these games are all low-level games. So you can use Raspberry Pi to develop games as well. So these are some of the most commonly developed applications done by Arduino and Raspberry Pi. Okay, let's take a look at sensors. So a sensor is actually a device that measures physical inputs from its environment. So I will elaborate that. It measures the physical inputs from an environment. For example, the humidity sensor, it measures humidity from its environment. And then the temperature sensor, it measures the temperature from its environment. And the light sensor, it measures the light intensity from its environment. So something like this, it measures the input that is given by the environment. The sensors then convert it into a data that can be interpreted by either a human or a machine. So this is all done on the sensors as well. So once it's received its information, it will convert it into data that is human readable. So if you see the images, there's a lot of sensors on the image. So, but we will be focusing on only two sensors throughout this training. That will be the temperature and humidity sensor, and also the light sensor. So these are the two sensors that we are going to use throughout the training. Okay. First, we have this humidity and temperature sensor. Okay. So these sensors has two readings. One is the temperature, and the second is the humidity. So the sensor is able to record two different parameters. One is the temperature, and the other one is the humidity. So as for this temperature, the units will be in Celsius, and will be in percentage. And the measuring rate is from 0 Celsius up to 50 Celsius. So this sensor is able to measure up to this range of temperatures. For the humidity, okay, the units will be in percentage, and the measuring rate is about 20% to 80% of humid. Okay, so as we take a closer look on the sensor, we can see there are 3 pins on the sensor. All the pins are labeled. Okay. The first pin is VCC. You can see on the sensors it's labeled as VCC. So what is this pin for? This pin is which is the power input for the sensor. So this is the pin that will power up the sensor. and start to receive the information from its environment. So it uses from up to 3.3 volt to 5 volt. So this is applicable for Arduino. It's just the correct voltage range for Arduino to power up. Okay, the next pin, the second pin, is the data pin. It's labeled as DATA. We call it the data pin, and which is the analog output pin. So this is the pin the Arduino reads the analog reading from the sensor. So once this pin is been connected to the Arduino, this is the pin where we read the readings, the temperature and humidity readings. And then the last pin is the GND pin. GND here stands for ground. This pin is the pin that completes the circuit of the sensor. So we avoid short circuit. The sensor has reading 5 to 10% deviation, which the accuracy of the sensor is about 5 to 10% off. So you can see, as you can see, there's a red LED there. The function of this is when the sensor is powered up, the LED will light up, indicating the sensor is working fine. Okay, next we will have this light sensor. Okay, we'll be implementing this tomorrow, so we can have a quick look on this tomorrow. So this is the light sensor. The sensor has only one reading, which is the brightness. As for the light sensor, the units will be in brightness. The measuring rate is from 0% up to 100%. So as we take a closer look on the pins, there will be 4 pins on the sensor. All these pins are labeled also. The first pin is VCC, which is the power input for the sensor that power ups the sensor, again from 3.3 volt up to 5 volt. So any voltage between this can enough to power up the sensor. The next pin is the GND pin, which I repeat again, is the ground pin, which completes the circuit for the sensor. And then the third pin is the DO. It's labeled as DO. Call it the DO pin, which is the digital output pin. This is the pin the Arduino reads the digital output reading from the sensor. And the last pin is the data pin, which is the same as the previous sensor. It reads the analog output. This pin is the pin where the Arduino reads the analog reading from the sensor. So why there are 2 pins on this depends on the user. Either they want to read digital or analog. So as you can remember, digital, it only gives you 0 and 1, which tells you that the sensor is on or off. Another one is the analog output, which gives you the information that the sensor is reading what kind of information, what are the range of light intensity which is reading. Okay, another thing we have these LEDs on the sensors as well. See, there's 2 LEDs. So this is to show you that the power up LED and also the DO LED. So the power up means when there's power to the sensor, this LED will light up. Another one is the DO LED, means when there's digital output, this LED will light up, indicating there's data transferring from the board to the sensor, or from the sensor to the board, either way. And then you can see this blue square sensitivity control. This is actually to control the sensitivity of the light. If you don't want it to be too sensitive, you can adjust according. Some sensors are too sensitive to light. Even in a dim room, it's able to detect light. So we can adjust accordingly to the way we want to read the data. Okay, the sensors has the sensor reading of 5 to 10% deviation as well, which is the accuracy of the sensors reading is off from about 5 to 10%. So these are the 2 sensors that we will be using for this project. So repeat the humidity and temperature and also light sensor. Okay, so this is what we are trying to achieve in this training. So in our project, the Arduino will act as a gateway to retrieve the data from the sensors. And then the Raspberry Pi will act as a PC to receive those data. Okay, not sure whether everyone knows gateway. Gateway here means it's a piece of device that allows data flow from one end to another end. It can be a middle person from data receiving and to transfer the data. So that is what exactly the Arduino will be doing in this project. It will act as a gateway to receive the data from the sensors and then transfer it to the Raspberry Pi using serial communication, which is the wired one. Because Raspberry Pi, most people will be asking, why don't I just use Raspberry Pi to read the sensors? That is the disadvantage of Raspberry Pi, which Raspberry Pi individually is not capable of reading analog values. So you take a look on the previous I explained, there's no analog output or input for Raspberry Pi. That is why Arduino comes in to read the analog values from the sensors and then transfer it to Raspberry Pi. Okay, so that is the flow. Once the Arduino has received the data from the sensors, it will then transfer to the Raspberry Pi. So once it receives the data from whatever data that we are reading from those sensors, from both sensors, the Arduino then will transfer it to the Raspberry Pi using serial communication. And then node rate. Node rate will be installed in your Raspberry Pi. Function of node rate, you will read the transferred data in the Raspberry Pi. So once the Arduino transfer it into the Raspberry Pi, node rate will read the data in Raspberry Pi through the serial combination. So basically the flow of this project is from the sensors to the Arduino, then to the Raspberry Pi, then to node rate. Node rate is for the final application, whereas for dashboarding purpose. So that's what this tutorial is about. So we are putting these two together over USB and serial communication. We're putting these two boards together over serial communication. This wired connection is a great way to show how these two systems are like. Arduino as a microcontroller and the Raspberry Pi as a single board computer. Both are actually board. So how are we able to make this board work together? That is what we are going to go through on this training. So let me go through the flow again. Arduino to Raspberry Pi and node rate. Node rate here is the software that's already been installed in your Raspberry Pi. You don't have to worry about that. You continue that tomorrow. So this node rate will take those information that is given by the sensors and it will be displayed as a dashboard on your monitor. That is for your visualization part. Okay, this is all for today.